Hi, for this video we'll be going through the rate of change and slope. So what is rate of change is basically the change of y over the change of x with the slope. Okay, so by knowing the rate of change you can find the gradient of the individual roller coaster. So these are the few famous roller coaster in the world, which are some are totally vertical, some are horizontal, and some is up and down. It's like a x square graph or x cube graph. So you always write a roller coaster from left to right, so you will also see a graph from left to right. So there are 4 different slopes that you need to know. First of all will be a positive slope, where you can see from left to right the graph is going upwards. Second, left to right the graph is going downwards. Okay, the last two kind will be a 0 and a undefined slope. Okay, horizontal will be termed as a 0 slope, where vertical will be defined as an undefined slope. So let's recap the 4 kind of slope: a negative from left to right, positive from left to right upwards, 0 horizontal, vertical undefined. So the 3 ways to calculate the slope is, first of all, to find 2 points of a graph that is nicely valued. So for example, you can see that I take a point which is not too near, which is slightly far apart, yet they have a nice value. So always try to find a nice value in a graph where you can plot nicely the rise over the run. Okay, we will do more example later. So the gradient will be vertical change over the horizontal change. So the rise will be the vertical change, the run will be the horizontal change, the x-axis and the y-axis. So the last part is to always remember to include a sign, whether is it positive or negative. So the rise you can see here is 2 unit, where the run is 1 unit. So it will be 2 over 1, which equals to positive 2, because left to right the graph is going upwards. Next, you can see this example, the rise is 1, the run is 3. So it's 1 over 3, and you can see that from left to right the graph is going downwards, so it's negative 1 over 3. Next, you can see here the rise is 2. The rise is 3, the run is 2, so it's 3 over 2, and include a sign positive 3 over 2. So the last example, run is 3, rise is 1, 1/3, downwards negative 1/3. So this another example you can see from the graph here. What you want to find is which section is the steepest. So the only you can do is from A to B, B to C, C to D, find the vertical range and the horizontal range. So from A to B, the vertical range means the rise is 1 unit. For 1 unit is 10 feet, so it's 10 feet. B to C is 4 unit, 40 feet. C to D is 10 feet, which is 1 unit. So A to B, B to C, C to D are all 30 feet long. So then you can find the gradient from A to B, B to C, C to D. So it's 1/3, 4/3, and 1/3. Okay, so it's 1 over 3, 4 over 3, and 1 over 3. So from here you can see that since B to C is the largest, so B to C will be the steepest. So now you have another example of an individual point. So the first point is 5 to negative 3. The second point is negative 4 to 2. So the formula of the gradient is y2 minus y1 over x2 minus x1. So y2 will be 2, so it's 2 minus 3 over minus 4 minus 5. You should get 5 over negative 9. The second example, okay, you can find 0 is x1, y1, 4 is x2, minus 2 is y2. So when you apply the formula, minus 2 minus minus 2 over 4 minus 0, you should get 0. So this is a horizontal slope. So to summarize everything, there will be 4 kinds of slope: positive, negative, 0, undefined. So now you have a example where you have the time and distance, individual data. So what you want to do is to find the rate of change are constant or variable. So how do you do it? Okay, first of all, find out the individual slope. So the rise will be the distance because it is the dependent value, and the time will be the independent value. So it will be 3/5, the first one. The second one will be 6/10. Okay, the third one 9/15, and the last one 12/20. So when you find the individual rate of change of the individual point, what you can realize is that they have constant rate of change. So what can you interpret from the data is that since at any 2 point the slope is 3/5, so when you plot the graph you can see that it's a straight line graph because the slope is constant. Okay, so in overall, what he's trying to say is that for every 3 mile, he drove 3 mile for every 5 minutes. This is what the slope trying to say. So for example 2, you do the same thing to see whether is it constant or variable. So 3/1, 6/3, 12/6, 18/9, and 24/12. You can see that everything has the same rate of change except the first one. So the rate of change are variable because there is one different slope. So the example of a variable slope or variable graph would be a non-linear function where you can see that the rate of change at every point is changing. So this is the second type of non-constant rate of change. So for more examples, you will discuss more in the Facebook page at Secondary Math and Science. Yeah, so that's all for rate of change.